Imagine waking up to find a new island has appeared on the map. It sounds like something from an adventure novel, but it just happened in the remote wilderness of southeastern Alaska, and the story behind it is less a cause for celebration and more a serious warning. A mountainous landmass named Prow Knob, once a peak sticking out of a vast glacier, is now a fully fledged island. NASA satellites have watched this happen, meticulously documenting a dramatic transformation that serves as a powerful symbol of our planet's rapidly changing climate. This isn't a story told over geological millennia. It's a story told in the unnervingly brief span of a few decades. To understand how an entire island can be born in our lifetime, we need to travel back in time. The story of Prow Knob is inextricably linked to the story of the Alsek Glacier. In the early 20th century, this glacier was a true titan of ice. It extended a full 3 miles beyond where Prow Knob stands today. The mountain itself was completely enveloped by the glacier, a hidden peak buried in a vast, frozen expanse. In geological terms, it was a nunatak, a word for a mountain peak protruding from a glacier, like an island in a sea of solid ice. Let's fast forward to the 1960s. A glaciologist named Austin Post was surveying the area as the glacier began its slow retreat. He saw the peak emerging from the thinning ice and gave it the name Prow Knob because its distinct shape reminded him of the prow of a ship, appearing to cut through the remaining ice. But even then, Prow Knob was firmly locked in the glacier's grasp, connected to the mainland by an immense icy corridor. The first real hint of its future isolation didn't appear until the 1980s. In 1984, the Landsat 5 satellite, one of our earliest eyes in the sky for monitoring Earth, captured an image. It showed the western edge of Prow Knob just beginning to touch the open water of a newly forming lake, Alsek Lake. The rest of the mountain, however, remained fused to the mainland by that massive tongue of ice. What happened over the next 4 decades was a relentless and accelerating retreat. This process, where ice melts faster than it can be replenished, is not a mystery. It's a direct consequence of rising global temperatures. And Alaska is on the front lines of this change. The state is warming at a rate 2 to 3 times faster than the global average. This intense warming is causing a staggering loss of glacial ice. Let this number sink in. Alaska's glaciers are collectively losing more than 66 billion tons of ice every single year. That's an almost unimaginable volume of water, and it has to go somewhere. All that meltwater flows downhill, feeding and creating proglacial lakes, which are lakes that form at the edge of a melting glacier. In this case, the meltwater has been steadily feeding Alsek Lake, causing it to swell dramatically. Since that first satellite image in 1984, the lake has nearly doubled in size, growing from approximately 17 square miles to almost 30 square miles. This ever-expanding body of water has been steadily consuming the very ice that once bound Prow Knob to the mainland. The final, definitive moment, the birth of Prow Knob as an island, occurred in the summer of 2025. Sometime between July 13th and August 6th of that year, the last remaining isthmus of ice connecting Prow Knob to the Alsek Glacier finally dissolved. The connection was severed. This momentous event, the culmination of decades of glacial retreat, was confirmed by images from the Landsat 9 satellite. The roughly 2 square mile landmass was at last on its own, entirely surrounded by the waters of Alsek Lake. So, we have a new island. But what does this really mean for the future of the glacier itself? The emergence of Prow Knob is more than a geographical curiosity. It's a critical turning point in the life of the Alsek Glacier. For centuries, the island acted as a pinning point. Think of it like a boulder in a river that helps stabilize the bank. Prow Knob was a stabilizing anchor for the glacier's terminus, or its end. Now that the glacier has lost contact with it, the entire ice front has become far less stable. This dramatically increases its susceptibility to a process called calving. Calving is when massive chunks of ice break off from the front of the glacier and crash into the water, creating new icebergs. Without Prow Knob to act as a buttress, the Alsek Glacier is expected to start calving much more frequently and across a wider front. This could accelerate its retreat even further, creating a dangerous feedback loop. Faster melting leads to more instability, which leads to even faster retreat. This increased instability poses a number of serious environmental risks. The formation and rapid expansion of proglacial lakes like Alsek can alter entire water systems, increase the transport of sediment, and disrupt downstream ecosystems. But the biggest worry is the heightened risk of a catastrophic event known as a glacial lake outburst flood, often abbreviated as a GLOF. These happen when the natural dam holding back a glacial lake, whether it's made of ice or loose rock and sediment, fails suddenly. This can release a biblical amount of water in an instant, causing devastating floods that can wipe out anything, including human infrastructure, for miles downstream. The birth of Prow Knob is a clear signal that this entire glacial system is becoming more volatile and unpredictable. But amidst this sobering reality, there is a fascinating scientific opportunity. The newly exposed land of Prow Knob, scoured completely clean by millennia of glacial ice, is a blank slate. It's a perfect, natural laboratory for studying the process of primary succession. Primary succession is the scientific term for how life begins in a place where no life and no soil has existed before. Scientists now have a front-row seat to observe how an entire ecosystem is born from scratch. The very first colonists to arrive on this barren, rocky landscape will be incredibly hardy pioneer species. These are organisms like lichens and mosses, which are capable of surviving on bare rock and in nutrient-poor soil. As these pioneers live and die over many years, they'll slowly break down the rock surface and begin to create the very first thin layer of organic soil. This process makes the environment slightly more hospitable for other plants. Their seeds might be carried in by the wind, or perhaps dropped by birds that stop to rest on the new island. Over time, as the soil deepens, other plants will begin to arrive. Over decades and centuries, we would expect to see the arrival of shrubs, and eventually, perhaps, even a forest of trees taking root. Studying Prow Knob will provide invaluable, real-time data on how life adapts and responds to the kind of dramatic, rapid landscape changes that our warming climate is causing all around the world. In the end, the story of Prow Knob Island is so much more than just a new dot on the map of Alaska. It's a stark, powerful, and undeniable symbol of our changing planet. Too often, the concept of climate change can feel abstract, something we discuss in terms of degrees Celsius, parts per million, and complex future projections. But here, we can see it. We can see the ice retreating. We can see the lake expanding. We can see the world's geography being actively and permanently rewritten before our very eyes. The birth of this island is a geological event happening on a human timescale, and it's driven by our collective actions. The story of Prow Knob is a clear and urgent call to action. It underscores the critical need to address the root causes of climate change and to protect the world's remaining glaciers. They are not just beautiful, static, frozen landscapes. They are vital components of our global climate system and incredibly sensitive indicators of our planet's health. The birth of a new island, born from melting ice, is a fascinating geological event, but it's also a profound warning of what we are losing and what we stand to lose if we fail to act.